So we just talked about measuring position from these sensors, but often we also want to measure velocity. Since we'll be talking about how to do haptic rendering, that is creating virtual environments that we want, sometimes we want to create haptic virtual environments that require that you know the velocity of the user. Now, there do exist straight-up velocity sensors, but we typically don't want to add those onto our haptic devices. And so instead, we'll take the position we already have and we will differentiate it. And the advantage there is you get to use the same sensor as the position sensor. And the disadvantage is that you'll get a noisy signal. There is an alternative. If you are happening to be using an encoder, you can measure the time between the ticks on the encoder rather than measuring subsequent positions. So here's how you would differentiate your position information in a very simple way. You can do it in more sophisticated ways, but this will definitely suffice for your hap kit. So here's a simple example. You could take 20 readings and then you could average them and you could put those in a variable called P1. And then you can average the next 20 readings and you could put those in a variable called P2. And then you could use this equation here where the velocity, this V here, is not voltage, but velocity. That velocity is going to be P1 minus P2 divided by the period of the haptic loop. So you do have to have an estimate of the period of your haptic loop in order to make this velocity estimate. Again, I want to remind you that differentiation increases noise. So you might have a position versus time plot that looks like this, which looks relatively smooth, but you can see I've added a few kinks into it. If you did a simple differentiation, a discrete differentiation like this in order to get velocity measurement, you're going to see it jumps all over the place. And depending on how much it jumps, that could disrupt any haptic effect that you try to create based on that velocity measurement. So you just have to keep that in mind. If you're trying to create a haptic effect that's based on a velocity measurement and it feels a little noisy, it may be because your velocity differentiation method is too noisy and you might need a more sophisticated technique. I'll also mention that if you are using an encoder, there's this time between ticks method. And that's because encoders fare poorly when you have slow velocities, and that's because there are very few ticks during a single loop of your hap kit or an Arduino. So you can get specialized data acquisition boards, which is not hap kit. So I'll emphasize this is not something that the hap kit is set up to do, but it could be a fun project for someone to do if they wanted to design their own, that use a special chip that measures the time between ticks. And if you have a very high frequency clock on that chip, you can measure that very accurately. And so you can do something like this. You can say, now I'm going to measure the amount of time between a set of two positions. It really winds up being a very similar equation to the discrete differentiation, but now you're getting the information in a different way. Now this fares poorly at high velocities, so for encoders, sometimes it's a good idea to switch between this method and the more standard discrete differentiation method, depending on whether you're moving slow or fast. Finally, we've talked about measuring the actual velocity of some signal, but typically that signal that we're getting is going to be in the joint space. It's going to be of the sensor itself. But what we really want to know in order to render some sort of haptic virtual environment is what is happening at the haptic interaction point where the person is holding onto the haptic device. So for that, we need to use forward kinematics, which tells us the haptic interaction point based on the joint position and the geometry of the device. And our lecture, which talked about transmissions, gave us equations for those forward kinematics. So how do we calculate velocity if we know those forward kinematics? Well, it's actually very simple. If you have a very simple 1 degree of freedom system like the hap kit, you can use the same transmission ratio to compute the position as the one that you use for velocity. So this is position right here. This is something that we derived for the hap kit, and it was that x handle equals this transmission ratio times the theta of the pulley, the angle of the pulley. And if you differentiate this, you actually get the exact same equation, except now you have the velocity of the handle in Cartesian space, that is the translational velocity of the handle, and the angular velocity of the pulley. And this transmission ratio is exactly the same as it was in the position case.